Good afternoon, everyone. Thank you very much for joining us today. We are going to start with the presentation. We're going to ask Shabazz to a few words of welcome and then move on from there and start with the presentations of myself, Nicholas Knoll today. Shabazz, if you go ahead and start your introduction and hello to the customers, you're welcome to do so.
Hello everyone, on the behalf of EDDIES Engineering, I hope everyone can listen to me properly.
Yeah, you're fine.
So EDDIES Engineering and Solution is a company in Pakistan that cooperates with the original equipment manufacturer in NDT inspection and condition monitoring. We provide equipments and turnkey solution for every type of inspection, including ultrasound inspection, electromagnetic inspection, magnetic inspection, dye penetrant, radiographic inspection. So we have a pack of OEM, and along with we have a technical manpower that can handle all your technical queries and able to resolve your issues according to code and standard, and we try to accommodate requirements like regular and from end users. So anything related to NDT, you can come up with us and you can discuss, and hopefully we will get you some solution through our partners like Gammatec in South Africa for radiography and Osiris in Belgium. So this session is for close proximity radiography, which is well known worldwide, and in Pakistan we are about to introduce this technique. It is more reliable, more safe, and more technical in terms of more good in quality as compared to already used the technology in radiography in Pakistan. So hopefully Jan will explain all the technical things and will introduce the practical part of this technique, and hopefully you have some questions so you can ask, and hopefully we're looking for a very interactive session. Thank you. That's all, Jan, from me.
Shabazz, thank you very, very much. And once again, thank you everyone for joining us. And yes, definitely, I think you touched on something very important there, working and to introduce this technology into your region with yourself from EDDIES. We appreciate the opportunity. One highlight thing that you said there definitely is safety. I think from my side, obviously, the first thing I need to do is apologize for what I look like today. I had a bit of an incident with an airbag, but everything is a bit of a, you can take and learn something from anything that you do in your life. And after having a little bit of a car accident over the weekend and ending up with some bruises, the first thing that comes to mind is safety. And if you think just to only a few years ago, that airbags in a car was not a standard item. It's not something that you look in the cars. There's only some manufacturers that adopted this technology into their vehicles. Fast forward 15 or so years, you would not buy a car without any airbags, without the safety feature. And today is definitely, that is what the projectors that Osiris and Gammatec bring to it, and the close proximity radiography brings to the table, is that safety concern. And that is the ALARA principle. And absolutely, we feel that this is the way and the way to adopt for radiography into the future. So definitely something to learn about that. We are going to start off with Mr. Nicholas Knoll from Osiris. He's going to do a short presentation on the circuit projector. We're going to just follow one or two simple rules. We're going to keep everyone on mute for the entire presentation. If you at any stage have any questions, please type them in the chat box. We are going to be actively monitoring the chat box for your questions after the initial presentations are completed, and of course the live GamCPR setup that we're going to do today with the 60 query source we will then actively answer the questions that have been posted to the chat box. With that in mind, we are going to kick off. I'll hand over to Mr. Nicholas Knoll from Uzrix to give us a short introduction on the Exerter Circa projector and all the safety features and items that come along with that. We are going to share his presentation and get him talking from there. Nicholas, give me 1 second. I'll get your presentation up.
No problem. Thank you very much, Jan. Hi, everyone. It's nice, and thanks to the technology, to be able to have one and myself, Belgium. Okay, so as Jan said, safety is more and more important, and nuclear authorities now are very dedicated to as low as possible, which obviously obliged company like Gammatec and Odorix to develop new products. So slide. And obviously, if we can you go to the next? Okay. Obviously, it's obliged company like us to develop new things. So this is the objective of Ozerix. So working in the close proximity environment. In this presentation today, you have two things. First, you need the projectors, and then you need a bunch of accessories and set of things that Gammatec has developed a long time ago, but now they have a very nice system. So in terms of the projectors, Ozerix has a large range of camera, but one of them is the Exerter Circa, which is I think one of the unique camera that can be used in a flexible sorry for that. It can be used in a very different environment. So this camera is a very compact, it's very light, it's roughly around 8.3 kilos, without collimator, without accessories. And it's a tungsten camera. I will talk a little bit later about the advantage of this. Compact, light, and obviously all the safety features. And this camera, if you work as a close proximity, it will reduce drastically the number of doses that the workers can get. So Jan, you can go to the next slide, please. Thank you. Okay, so you can see the camera is actually very light, very small. We sell this camera around the world more than 10 years now, so it's well accepted. People are using for either traditional work, the same work that you do today with mainly the 880 in Pakistan. So you can use it as a traditional one, but mainly you can use it as a close proximity one. As you can see in this camera in the slide, there are 3 colors, 3 signals. Generally, you guys have, you used to use 2 colors, the green one when it is safe and the red one when the camera is activated. In the Ozerix projectors, we have introduced another color, an additional one, which is the yellow one. It's to include more safety, as we discussed in the beginning. So this yellow color is actually the latest and the last one, the last safety before activate the camera. So everything needs to be connected. So you need to connect the guide tubes, you need to connect the collimator, you need to connect the wind out, and you cannot activate the camera until everything is connected. So this is absolutely impossible. So safety again. So before activate the camera, you will be with the yellow color, and when you will push the small lever just below, and you can see it just below the handle, then the signal will become red. We have this camera only for selenium. It's only for selenium. We talk about selenium 75 today. It's less energy, and the straight channel is different than what you normally know. Normally you have a S channel on iridium, but because selenium is an isotope with less energy, the straight channel can be used in this camera. Next one, please. Okay. All right. So what what does the camera can do? So as you can see in this camera, we talked about tungsten. This is completely new for most of the camera. Indeed, now the 880 that you use, they use a depleted uranium shielding, which is a lot of administration work, because each time you move depleted uranium from point A to point B, you need to declare it, you need to declare the number of weight. This camera does not have depleted uranium. It's a shielding with tungsten. Tungsten is absolutely good for selenium. And this camera, if you do not have a source inside, can be shipped by normal post. So you can ship it by FedEx, you can ship it by TNT. It's very easy to ship it. Selenium can produce and give you an absolutely good image up to 30 millimeters of thickness. And the result that you can get with selenium is close to the one you can get with X-ray. Selenium has a longer half-life, so you can keep the selenium source longer than an iridium one. And this camera can be used either as a type A with a maximum of 80 curie of selenium, or you can use it with a BU certificates, and then you can push up the activity up to 100 curie. All the test has been done in this camera, and this camera is ISO 3999 approved. And what else can I say here? I think nothing more than the fact that this is the future for people who wants to work in a very close environment and who wants to decrease the doses to their workers. It's now bringing me to the last slide, talking about this camera. Osiris can propose a camera now with 3 versions. Either you have a version with a maximum of 40 curie or 80, then you can use the 2 of them as a type A, and then we can propose one with a maximum of 100 curie selenium, and then in that case you need to use the one with the BU certificates. Camera are in stock, selenium is in stock, and now I let Jan continue in the presentation and show you the great features they can add to this camera, and talked about the GamCPR.
Excellent, Nicholas. Thank you very, very much. That was very informative. We do appreciate that from your side. And anybody, please, if you need any additional information on this projected type, please speak to EDDIES Engineering, get in touch with them, and we can work from there. All right. For the rest of the day, for the rest of the webinar, we are going to jump more or less. That's the same one. More or less right into the presentation. If you give me 2 seconds, we are going to open that. There we go. Zoom. Share my screen. Everybody should be able to see that. And we will start off. So once again, welcome everyone, and thank you for joining our webinar on why should asset owners and production facilities consider using close proximity radiography. We are honored to have you here today and to meet all with you, and appreciate your time and attendance for this. We appreciate the opportunity to showcase to you the advancements that have been made and that are available in terms of radiation safety utilizing close proximity radiation systems. Today we will start from my side, firstly with a presentation on close proximity radiography, the safety and the cost savings, the increased radiation safety, training and ALARA culture, how the GamCPR achieves close proximity radiography doing live setups, and then we'll take the questions after we are done with the live setup. We will read the questions aloud for everyone and then give them answers live. So please feel free to post your questions in the chat box. All right, for today's presentation, just for ease of reference, when we refer to CPR, this is meant to as close proximity radiography as a genre in its totality. And then if we talk about the GamCPR, that is the Gammatec specific system that we've developed to achieve close proximity radiography. Okay. Contents for today is CPR explained, where to use CPR and why, what are the most common CPR shot applications, and why choose GamCPR. Okay. We'll start with what is close proximity radiography. Close proximity radiography, or CPR, is the conducting of radiography in close proximity to authorized radiation workers, members of the public, or radiation-sensitive monitoring devices in such a way as to ensure continuous operations. CPR is achieved by utilizing a system of X-ray or gamma ray emitting devices, incorporating specific collimation with rigid and or flexible shielding to reduce the primary beam and scattered radiation to safe levels at the desired barrier distance. You will see on the slide a visual comparison between conventional radiography on the left and close proximity radiography on the right. The GamCPR system was specifically developed to ensure higher productivity rates, not only for the NDT and radiography teams, but to ensure cost savings, increased productivity, and increased radiation safety throughout the entire worksite. We'll look at where to use CPR and why. We know that wherever radiography is being conducted, there are large exclusion or safety zones where other workers are not allowed to enter. With close proximity radiography, we are able to keep workers at their designated posts. Restrictions on movement within a site causes lost productivity, stops production, and affects planning in all departments, not only where radiography is being conducted. By utilizing CPR, you can avoid general workers not being able to get to their designated posts or conduct their daily tasks because of the access issues while radiography is being conducted. You will have no closed roads where piping runs nearby, no instrumentation engineers unable to do their daily checks, no other NDT work around the same areas influence, accelerating shutdowns and improving on productivity in general. So you can ask yourself, how has conventional radiography impacted your work programs in the past? What if you could reduce the safe working distance and the production downtime through lower radiation levels in the work area? Would using close proximity radiography benefit yourself and your customers? We're going to look at where should plants use close proximity radiography. Almost anywhere where radiography is required. GamCPR provides massive cost and productivity benefits when utilized during shutdowns, during maintenance and turnarounds on plants, in areas utilizing radiation-based technologies for process measurement, new build projects to accelerate construction programs, and of course, can be used onshore as well as offshore. If you make use of the close proximity radiography system as listed here, you will have no shifts lost due to radiography. You will change downtime into productive time. You will accelerate construction programs, and you can maximize the plant utilization. You'll have a quicker startup and return of the plant to the asset owner. So why should asset owners in production facilities consider using close proximity radiography? We will break this down into 3 simple reasons and discuss them. Firstly is the massive cost savings, because work can continue 24/7. Radiation safety, you can achieve true ALARA, a principle for general workers and the radiography teams. And you'll have improved image quality, because you are utilizing a selenium-75 source that provides high quality radiograph and works excellently with digital radiography solutions. Firstly, let's look at the massive cost savings. The GamCPR reduces the safe working distance and eliminates conventional radiography windows, eliminates the need to evacuate an area, and maximizes the plant utilization. We will again we'll eliminate those conventional radiography windows. We'll have no shifts lost due to radiography. You will change downtime into productive time. You will accelerate your construction programs, and you can maximize plant utilization. You'll have quicker startup and return of the plant to the asset owner. Secondly, is radiation safety. CPR will enable you to reduce radiation levels on site for everyone. You will reduce dose rates to radiographers, ensuring the safety of your teams. You will reduce and eliminate dose rates to members of the public. You'll reduce the chance of radiation incidents because GamCPR puts the radiography team in control of the barriers they need to achieve, and they know exactly what to expect when going to site. There's no more chance of scatter radiation or of someone unknowingly entering the radiation barrier zone. This is a key advantage of undertaking close proximity radiography, because the radiography team will be empowered to be in control of radiation levels. Utilizing the GamCPR system, we get barriers down to only a few meters versus conventional radiography that could have exclusion zones of up to 100 meters and sometimes more. You also make the entire site a safer place, a far less area to keep safe, and you keep the public out while radiography is being conducted. Let's look at the third reason. You will then improve on image quality. By using the radioactive source that will provide high quality radiographs, the use of the selenium-75 source for industrial radiography has gained wide-ranging acceptance. The advantages of that over iridium-192 are, in short, improved contrast, better sensitivity, improved resolution, and a lower energy range that is easier to shield. And of course, with the selenium-75, you have a longer half-life compared to iridium of 120 days. So that covers the advantages of running a close proximity setup on site. Now we can look at the system itself and see what it is made up of, and how then we achieve and ensure safe close proximity radiography. Okay. The first that we need to know when doing and achieving close proximity radiography is the knowledge that we have about the systems and how close proximity radiography works. Knowledge of how radiation works and using purpose-built equipment. So we know that time, distance, and shielding are the basic laws of radiation safety. We improve on shielding to reduce the distance and therefore time spent exposed to higher levels of radiation. We utilize the lower energy of the selenium-75 source. That's the knowledge that we have. We use the uniquely designed selenium-75 gamma ray projector, the circa 80 as said in the presentation earlier. We use purpose-designed collimation with the knowledge that we have. We use flexible and purposely designed high-density shielding materials. And then we create a safety culture of as low as reasonably achievable with a LARA. The second item that we have in our arsenal is, of course, the training. So training, Gammatec gives a comprehensive training to each GamCPR customer to ensure a good safety culture and that safety objectives that are aligned with the LARA. In the training, we will teach users the following things. We will teach them how to achieve close proximity radiography. We will teach them how to utilize and deal with primary beam shielding, how to deal with scattered radiation. Then we'll also teach them all the calculations and methods pertaining to close proximity radiography. We'll also teach them the best practices relating to equipment use and maintenance. Now, before we jump into what the system consists of and our live part of the demo, we'll quickly discuss and ensure the system is made for purpose on site and that it can be used in a wide array of applications in the following slides. So, what are the most common CPR shot applications? Here you will see the most common shot applications. The system is flexible enough that it can be adapted to any radiography work that needs to be undertaken to get close proximity radiography or lower down the radiation barriers on site. GamCPR system uses uniquely developed system of clamp stands and shielding mats and other accessories to allow for radiography on various pipe configurations, including pipe to pipe, pipe to elbow, pipe to T, pipe to reducer, pipe to flange, and even pipe to socket. Some of the pipe configurations and that the system is adapted to will run through here. You can do contact shots using the collimator and the shielded guide tube. Use a contact shot with the projector wrapped up, depending on the space. You can do a contact shot with our specially devised scatter cone. You can do a standoff shot forward ellipse with a cone up to 2 inch. And also a standoff shot forward ellipse wrapped up to and then a superimposed with a cone up to 2 inches. And then do a contact shot with the projector wrapped in a pipe to elbow configuration. Further, a contact shot using the collimator and the shielded guide tube, also close to the elbow, if space does not allow for it. And then, of course, we can do a standoff shot backward ellipse or superimposed, wrapped up to a 4-inch pipe, utilizing the GamCPR system. Further configurations is pipe to T configurations, and then you can do the same thing. Contact shots with the projector wrap, a contact shot using the collimator and the shielded guide tube for where space is at a premium, and of course a standoff shot backward ellipse or superimposed up to a 4-inch pipe with the T configuration. Pipe to reducer, very much similar to straight pipes. We can do contact shots with the projector wrapped, contact shots with the collimator and the shielded guide tube, and a standoff shot backward ellipse or superimposed up to a 4-inch, utilizing the right items in the system. And a very interesting one is the pipe to flange configurations. So there we can do a contact shot using the collimator and the shielded guide tube, or we can do a standoff shot backward ellipse or superimposed wrap up to a 4-inch pipe. That covers, the last one is pipe to socket configuration. We can do a standoff shot there, superimposed wrap up to 4-inch. So that covers all the existing setups possible with the standard GamCPR kit. We can, of course, custom make and test specific applications for a customer if the requirement is there, and we will design what is needed to achieve close proximity radiography. You can get in touch with us or with EDDIES if you have a unique application that has not been listed here in the configurations today. Okay, then to briefly touch on our constant development and the next design phase for the GamCPR system. What you can see here is the T-weld configuration for tank applications in not only existing builds, but in new builds, where we are looking to achieve close proximity radiography in such a fashion that radiography can be conducted while tank construction and welding is underway in the same space. Next up is the profile shot. We're developing a profile shot configuration for corrosion and wall thickness applications. And that's it, that's what's coming. GamCPR, obviously, is on a constant development at Gammatec. If you have any interesting applications, or if your customer has any interesting applications and a problem for us to solve, please get in touch and we'll make sure that we can take it up and move it from there. We're going to quickly look at why you want to choose the GamCPR system specifically. Firstly, it's that circuit tungsten projector. It's a lightweight field loadable system weighing only 8 kilograms. We've got purposely built collimator and apertures to ensure close proximity radiography and to reduce the radiation beam to within only the shielding footprint. We've got the specifically designed clamp and stand system. It's articulating arms, allowing for fast setups, flexible, robust shielding mats. The shielding mats covers a wide range of pipe configurations that are made easy with the flexible shielding material around user-friendly clamps and stands. And then, of course, we've got our unique safe working distance calculator to quickly calculate essential parameters for radiation safety. The next slide touches on the circa 80 tungsten projector that you've already heard the presentation on. We will skip that. Secondly is the collimation and the shielding. And on screen, you will see here various mats of various sizes, cones for scattered radiation, and collimators, ensuring that we have the best shielding in the business at this stage. Of course, simplicity and ease of use. We know that the specifically designed clamp and stands gives us fast projector setup times on a wide range of pipe configurations. And it's made very easy and user-friendly to allow for contact shots and standoff shots on those wide variety of items. Then lastly, from my side, is the simplicity and ease of use of our Gamma calculator, GamCPR calculator. This enables the user to calculate exactly what he will need to achieve the correct readings at the barrier. The calculator is a multifunctional and can be used to calculate the following items. You can firstly calculate the readings at the barrier with the specified number of shielding material. You can calculate the barrier distance with the specified number of shielding in place. You can also calculate the Curie strength of the source needed to achieve set barrier readings. And then lastly, you can calculate the shielding required with a set barrier distance or with set barrier readings that are required. The GamCPR calculator was developed with real-world setups and trials to calculate the reduction curve created by the different shielding materials used in the GamCPR system. So thank you. That's it from the presentation. Watch the space. We are constantly developing the GamCPR system. I'm going to hand you over to Mr. Ivan Leroux and Mr. Philip Borchardt. They're going to run us through 3 different shot setups today live. We are using a 60 Curie source. We have a radiation survey meter here so that we can show you live readings and show you that there is a source in the projector currently. And we'll do those 3 setups live, and then we'll move across to the questions. Ivan, thank you very much. Go ahead.
Good afternoon, everyone. Good afternoon, everyone. Can everybody hear me? So as Jan Albert has mentioned, today we will demonstrate 3 different types of shots using our rig at the back. We will be using a 60 Curie selenium 75 source and the circa 80 container to do that. To save time, we have started with a contact shot on a 6-inch pipe, which we've wrapped with 3 layers of primary beam shielding as well as our scatter cone. What we'll do now is we'll just add an additional 2 layers of shielding material in the primary beam area because we are dealing with a 60 Curie source and we need to achieve a safe barrier at 3 meters. Okay, so now we will expose the source. For the purpose of the demo, we're only using a short piece of guide cable and not the entire length of winding mechanism. Okay, so the source is currently exposed, and we will show you the readings at the 3-meter barrier in the primary beam shortly.
Yeah.
So at roughly 2 meters, we are below 2.5 microsieverts.
We'll just quickly show you on the mobile camera the shot setup we have here. Okay, we've done 90 degrees just to show you that any angle is possible. Currently, it is red, so the source is exposed, and that's the setup to get that right. If we come right up to it, as you can see, we are very close, at only a couple of centimeters away. We are at about 36 microsievert, and if we come to that 1 or 2 meter barrier back, it drops down to under 5 microsieverts very quickly. Excellent.
So what we'll do now is we'll break down the shot and explain the different parts of the system. So as you would have heard in the presentation, we make use of bismuth impregnated silicon mats for shielding. We've cut slits into the mat itself to allow us to weave Velcro through them. And I will show you on the inside, we've got a embedded layer of Kevlar, which strengthens them to allow us to do that without them tearing any further. So this is what we call the primary beam mat. It's large enough to cover the primary beam, and we normally use about 3 layers of these per setup. So what we've got here is a prototype scatter cone. It's very rough at the moment. We've just developed this to reduce the need for mats around the back. This simply drops over your collimator and takes care of any backscatter that might go towards the back. As mentioned, this is a prototype and it'll be cast in future as a one-piece design. So this is our CP80 collimator. It snaps onto the Circa container directly. It's got a concave surface, which means there's no flash of radiation when the source passes from the container into the collimator. Your kit gets supplied with 4 apertures, which can be interchanged or it can be used as a normal collimator. There's 4 different apertures in each set to allow you to get the best suited footprint for your desired radiograph. So there's another 2 of the 4. So in the calculator, it also factors in which one of these you use when you're exposing. So that takes care of the basic contact shot using a 6-inch pipe. What we'll do next is we will do a superimposed shot on a flange well at 450 SFD, and we're doing it in this orientation to show you the versatility of the system in various setups. So we've pre-clamped the clamping jig already. We will show you in some more detail how that works as we go through the demo. So first we have to take care of the primary beam. As mentioned, we add 3 layers of shielding. And the clamping system makes provision for a frame to create a box structure that makes wrapping easier without any mats interfering in your area of exposure and ultimately compromising your weld. So we've taken care of the primary beam. What we'll do next is we will take care of the scatter coming off the pipe and around. And we use what we call large mats for that. Basically just a bit longer than the primary beam mats and slightly thinner because it is mostly used for reducing scatter on the sides. And lastly, we will just add another layer of mat over the top to complete our box shape structure. And if there's any areas where there could be radiation escaping, like in this area, you could easily close that up with a standard red shot bag, which would just cover the openings that you might have because of the structure. So again, we are using a 60 curie selenium 75 source, and we will be exposing and show you the readings achieved.
So just over here, at 2.5 to 3 meters away, we are under 6 microsieverts, or at 6 microsieverts for the current 90-degree setup into the flange. So there is the setup over there. If we come this way, see again, under 5 or 6 microsieverts at 2.5 to 3 meters away from the shot setup. Just from a different angle, noting that we can do this from any angle and ensure that it works.
Okay, so that takes care of a quite difficult shot to achieve this barriers, which is the flange shot. The next shot we'll do is a standoff ellipse shot on a 2-inch pipe. We will just need a minute or two to break down the current setup, and we will set up completely from the start the standoff shot for the ellipse.
Guys, I hope you're finding this interesting, and I hope you're finding the readings very interesting as well. While they're breaking that down, just a quick explanation in terms of what we wanted to do here. We started a bit interesting. We found that if we do a normal vertical setup and a normal contact shot, people have lots of questions for, what happens on site if there's a pipe rack, if I have a funny angle to work at, things like that. So we said, okay, let's start with that. Let's start with the difficult stuff. Let's start with the 90 degrees. Let's show that you can use the system on a standoff or in a contact shot at any angle around your piping. In a pipe rack, with the projector setup, you can basically move that around as much as you want. The system is designed to take that. So we handled that. We handled difficult spaces into a weld and a flange with a standoff, and we've handled the 90-degree contact shot, wrap that up. We're now going to come into the more basic shots. Ivan's going to do, they're going to do the setup directly from the top here for a standoff ellipse shot. Now, again, the standoff ellipse, we're going to set it up vertically right here so that the camera angle is very nice and you guys can see exactly what happens. But in that same way, we will swivel the system 45 degrees this way, 45 degrees that way if you are doing A and B shots, or you can have it again out at 90 degrees, no problem when doing radiography. He's going to go through just one or two parts of the system to show you what is there. All of these are included in the standard GamCPR setup. So nothing that we do today here, you need specially manufactured parts for. It's the parts that are included in a standard GamCPR system so that you have the flexibility when you get to site, you can do any type of shot setup that you want.
So just to show you guys what the clamping system looks like, this is your basic clamp which attaches to your pipe. You make use of a chain. We do provide canvas sleeves with this if you do get a coated surface or coated pipe that you would not like to damage the coating. There's a normal canvas sleeve that you slide over the chain that just protects your surface. You tension it using a ratchet around your pipe, and then what we've added to this system is dimples on the adjustment legs. That just assists when you set up and you lock it in place. There's no possibility of your SFD dropping during exposure, which could result in a reshoot. So again, the base of this has got a V, which allows you to always set up in line with your pipe. So for this particular shot, we will make use of what we call the shielding cassette. Basically, instead of using flexible mats, we've got what we call a cassette, which makes use of 4mm thick lead sheets, and it can take up to 7 of those, meaning 28mm of lead, and that is just to reduce the primary beam. So this just slides over your L-shaped legs, and they get secured using pins with R-clips. Then we add our standoff legs. They are already at a predetermined 17-degree angle, which gives you a nice code-compliant ellipse opening when exposing. Again, they lock onto your L-shaped legs using your wing bolts and dimples. The next step is we drop our projector onto that and lock it in place. So what we've created for the ellipse shot is what we call the laser alignment tool. So basically it attaches onto your collimator aperture, and that allows you to perfectly align your area of exposure with your weld. That attaches to your collimator, and you would then align your weld with the laser. In this case, we are about 20 millimeters past your weld, which we can easily rectify by just moving your projector back to the correct position. And there we are 100% aligned with our weld. And in that case, we will lock our projector and collimator, and we can remove the laser alignment tool. The reason for a green laser is because it's visible in sunlight, opposed to our conventional red lasers, which is not that visible in daylight. So the next step is we will add our shielding cone. Basically, it's 2 stainless steel shells that has been filled with 5 millimeters of lead in between, and the sole purpose of this is to absorb the scatter that comes off your pipe and from your collimator. So that just drops into place. It's set at a standard SFD of 350 millimeters, but we do have an extension that you can set it up to 450. And then your setup drops onto your cone, and you lock it in place. And lastly, you secure this, although it can't fall off because it's over a pipe and it's engaged with a collimator. We always advise to just keep it in place with the Velcro strap, especially if it is in a plant where it's overhead, where people might be walking. So one of the questions we get is, we've aligned the center of our collimator with the center of the weld while we were high, and does it change when you drop your setup onto your cone? No, it doesn't. It's still perfectly in line with your weld. So typically we've just set it up straight because it's easier for the camera to see, but ideally on site you would do an A and a B shot at 45 degrees. So you do your first shot at 45, and you don't have to break down the entire setup to do your B shot. You just lift your cone slightly off and replace your film and your ident, and you would swivel your entire system to the opposite direction, and you do your B shot. So your second setup is a lot faster than your first, and at this stage we will now expose the same 60 curie source we used earlier. And as you can see, at 3 meters, we are below the 2.5 microsieverts. We are at, in fact, at 1.3 average.
Go a little bit closer. Still under 1 microsievert, close to the system, and 1 meter away. Just come around here. You want to go very close to show that there's a source in there? We'll do one. We'll come very close to the projector briefly, right onto the primary beam. You see it jumps. Now we are right up against it at about 10 microsieverts. Maybe go up there. Here we are, very, very close. You'll see the jump to 30 microsieverts. There we go. So definitely a live source in there, just very effective shielding from our side.
So that is the 3 shots we wanted to show you today. So if there's any questions, we are happy to answer them live or in the chat box.
What about the 360 shot? Is it the one-time setup and you move the camera along the angle to cover all the well joint?
I think you can go all around the pipe.
You can, provided there is space for your SFG and your container to swivel around. If you need to do 3 or more shots, yes, you can loosen the ratchet and swivel it around the pipe completely. Does that answer your question?
Yeah, thank you.
Okay, we're going to take a couple of questions that we've already had in the chat box, and we'll answer them live along what I can answer. I will answer. We'll ask Ivan as well. One of the first questions was from Abdul, and said, Abdul, how will the CPR be used for radiography of socket welded fitting as shown in the previous slide? If I think about our actual socket that we have there, it's still a socket clamped onto a pipe. If it's a very thin pipe, you can use the collimator. Maybe you can just show them the collimator. If it can't take the weight of the projector for that small welded socket, you can always use the collimator along with the mat, or you can do a standoff shot like this or a contact shot. So we've got a collimator over here. If it's a very thin pipe and it won't take the 8 kilograms of the projector plus the additional weight of the shielding mat, then you use the collimator here and wrap that up to make sure. The next question from Basit, it says the maximum diameter we can check. Basit, so we're actually limited by 2 factors. Firstly, by the selenium-75 source, selenium-75 up to 30 mils in steel. That's not diameter, that's your total thickness of the steel in your area of interest when you are calculating what shots you need to do. Secondly, for contact shots, we are not limited in diameter. If doing contact shots, you are only limited by the steel thickness in your region of interest. For standoff shots, we are limited up to 4 inches. But after that, you won't be doing standoff shots anyway. We can do up to a 1 and 2 inch pipe with the standard cone, and then there's an extension available for the cone that will enable you to do a standoff shot up to a 4 inch pipe as well. I hope that answers your questions. Let's see what we have here. Again, from Abdul, he says, what is the length and weight of the shielded guide tube? Ivan, maybe you can comment on that.
So the length is standard 500 millimeters and it weighs roughly 3 kilograms. Saying that we can make it at any custom length you prefer. Obviously, the shorter it gets, the more rigid it is. So we found that in practice, the 500 millimeters or half a meter works fairly well, which would allow you to gain access to the harder to reach areas 90% of the time.
Excellent, thank you, Ivan. That's awesome. Flippy, maybe you can grab a map there, maybe just a single one. The next question we have here is from Abdullah as well. He's asked, what is the weight per unit length or per unit area of the shielding material? Now, we make the shielding mats in two different sizes. Firstly is a 300 by 300 primary beam shielding mat. That is a little thicker. I think it's 12 millimeters, 12.7 millimeters thick. A single mat, roughly 3 kilograms. And then we make the large mats that you've seen. That is 900 by 300 millimeters wide. And that is about 9.5 kilograms for the large mat. Next question from Abdul, what is the safe operating temperature of the silicon mat?
Up to 70 degrees.
Celsius.
Yes, Celsius.
Up to 70 degrees Celsius for the silicon mats. Okay, the material of construction of the primary mat as asked by Muhammad. Muhammad, it is a silicone impregnated with bismuth material and some other shielding materials, all very secretive about it, but gives us very good shielding. Moin has asked here how to place the film on the elliptical shot. Film must be folded and get pressure marks due to the mats. For that elliptical shot, you shouldn't have any pressure marks. The cone obviously is hollow on the inside. You can fold your film around that if you want to. Keep it out the way. The cone fits nicely over it, and the adjustability of the cassette means that it just holds your film in place. You shouldn't have any pressure marks. We've also very successfully used the same system with CR cassettes for computer radiography without any pressure marks or any problems. Dabir has asked how the system could be used for cross-country pipelines, besides which varies up to 42 inches and a thickness of 17.5 millimeters. We would need some adjustment. On that, you can always do a panoramic shot on that. For the panoramic shot, you would need to utilize a crawler. You would need to still put shielding materials on the outside. You need to decide where your limitations are and then adapt the system to that. But that is something that we can obviously custom build for you depending on the pipeline that you're busy with. It is something that we are developing currently alongside a customer. We are building a small crawler. It will depend on the access. Obviously, if you have to use conventional crawlers that can go very far down a pipeline, it won't be that effective in terms of close proximity radiography because of the shielding required at the source and of course around the pipe. But if you've got short access areas where the weld, you can put a small crawler into it by hand, we can definitely help you out if you need us to develop a system like that. We've been asked also by Dabir, what would the cost be of the Exertis 120 and the CPR system? You can get in touch with EDDIES Engineering on that. We work very closely for them for pricing, which includes getting it to your site, getting it cleared, all the rest. Please speak to EDDIES for that. Navid has asked that you cannot penetrate more than 15 mils thickness, as it has to pass from 2 walls, which equals 30 millimeters. Not completely true. You're limited to 30 mils, but you're limited in your area of interest and how much penetration that is. So work that out very nicely. It is made for small bore piping. That is the kind of the meal ticket for these close proximity systems currently. Dabir has also asked up to what size of pipe the system could be effectively used. We've answered that for your standoff shots and your ellipse shots, up to 4 inches, standard 1 and 2 inch pipes or smaller than 2 inch. And then you get the extension for the cone, taking it up to 4 inches. For contact shots, we can make it any size you want. Maybe we should do a quick contact shot setup. We've got 2 projectors, to show them how we wrap the projector to the pipe. Doesn't matter. You just keep on adding mats. The limitation would be on your obviously on your scope of work and your setup by level 3. How big the pipe is for that contact shot that you could do. But we give you a couple of straps with the projector. They are very long. Obviously, the same collimator that comes on the front of the projector here that we have on the top. The same collimator comes in front here. And because of the strapping system and because of the mat, you can have any pipe diameter you want to. That is a simple contact shot, easy to go, very quickly. with the collimator that's on here, or you could, if there's no space, use the shielded guide tube and collimator over there. EDDIES has asked for the 360 shot. Can it be rotated? So is the setup time, is it one setup time for each joint? Yeah, like you've seen here, if there's enough space for the whole system to move around 360, you would set this up once. You might loosen up either the bottom or the top just to replace your film, swivel it over to the next one. Very, very quick turnaround, no problem there. Navid has asked for the approximate exposure time for 30mm thickness of steel in selenium 75. I have no idea. We would need to work that out according to a slide rule calculator. I am sure that EDDIES can help you out there as well, but from where I'm standing right now, I don't know. They've asked, how do we align with the weld joint for the second shot in the ellipse case? Now, when you loosen this up, it is not moving forwards or backwards. You are still perfectly aligned. When you go down, it will still be perfectly aligned with that circumferential weld, no problem. If you at any stage feel that it has moved, take it apart and check it. But by just swiveling it, there's still tension on the chain. By just swiveling it, you will not move forwards or backwards, and you already know you can mark off on your pipe beforehand where your A and B position is. There are marks on the collimator that you can align to ensure that you are in the right place by marking the pipe before you do your setup. Great. Guys, I think that's it from the questions in the chat box. If anybody else has a question, I think we do have a bit more time. Now is the opportunity to ask it, and we'll quickly answer that question. We'll give that 2 minutes or so for someone just to ask a question. If there's no questions, we will end the session, and I will give back over to EDDIES and Azar there to do the thank yous and end the session on the GamCPR system.
There's one more question.
Okay. The length of the cone is fixed. Yes, the length of the cone is 350 millimeters. And with the extension, that goes up to 450 millimeters for the cone. That gives you the perfect ellipse along with what the stand is there. If you need to do a larger ellipse, you just move it up as far as you want, but then you do not use the cone. The cone is for the 350 ellipse with the extension 450. If your specification requires you to have a larger standoff, use it along with the shielded guide tube or your projector higher up on the platform. How high can this go up in total?
450.
450 here plus here.
Yeah.
450 standoff.
Yeah.
Okay. And then if you can't use the cone and you need to get higher, you would then wrap this ellipse shot with the mats instead of using the cone. I see Ralph Davies has a question. Ralph, please go ahead.
Okay, I'm unmuted. Yanni, thanks very much. Just a question, I think that I'm sure EDDIES can answer to each client independently is EDDIES are geared up to import sources, particularly selenium and tungsten. And separately, I'm sure everyone will be asking about iridium, so I won't answer that. They are working on solutions. But just to clarify that Gammatec, Uzorix and EDDIES are authorized to bring in selenium sources in circa tungsten containers at any time, and we are ready to go whenever customers are ready, which I think is important that they're aware.
Sure, Ralph. Definitely, if anyone have any query, they can speak to some guys in EDDIES engineering. So it could be Asghar Ali, Fazan Rashid. They all are there to help. And definitely, if anyone needs the Circa system, we are ready to go.
And then thank you, Shabazz. Another point worth noting is Gammatec develops the entire system ourselves in conjunction with Uzurix. So we recently developed a panoramic system to shoot 10-inch to 48-inch, I think, pipes with a panoramic shot, a specially designed panoramic collimator. And so really, if there are specific designs, there were 1 or 2 direct questions asked by some of the individuals. We will answer all those questions with you, even if we haven't addressed them now.
Thank you very much, Ralph. We've got one more question that I think I've just skipped. They've asked if we can use the GamCPR system along with the SafeRad camera. Now, to the best of my knowledge, and you guys can correct me here, SafeRad runs a modified RID SE4P container, which, yes, the GamCPR system, we would prefer the Circa 80 as everything is in place as it should be. But if you do have a current RID SE4P, we can make it work. There's 1 or 2 adjustments we would need to make. There's maybe 1 or 2 extra items you would need to buy in the system, but we can make it work with the RID SE4P system if you've got a RID camera. Then I think most notably, while we are on the SafeRad type system, I think most people will note that SafeRad is a very good system. I think there's a lot of development that happened at the start of that there. But this system is not for rent. We don't come to your site to come do inspections, to come do work. This system is for sale so that you can do the work. We give you the training, we give you the system, you're in control of what you're going to do. There's going to be no other people or no other radiography companies working with, on your site doing radiography work. You purchase the system, you come back to us with improvements or issues that you've had on site. We make improvements to the system. We've had very good feedback from our customers. And at this stage, these types of barriers, can't beat them out there. We are the best in the business for that, and continually improving on the system. If that's all the questions, that'll be fine. Give me 1 second to quickly check. We've got a very good comment from De Beer that says the system is no doubt very good, and its introduction will of course be beneficial to the industry, especially radiography and plant. Dabir, thank you very much for that wonderful comment. We really appreciate that. Navidus asked, is the price less than 50% that of a Delta 880 or the same for selenium as compared to iridium? No. The projectors, I think the pricing is very much on par. This is what these types of systems cost. And of course, selenium is a little bit more expensive than iridium, but it's got a much longer half-life of 120 days. So you'll be using that source for a much longer time on site. Excellent. Gentlemen, any other questions out there? I'll just give it a couple of seconds and we can answer them. If not, then we'll end the session.
Thank you so much, Jan, everyone at the Gammatec. It was a very informative session. And really, it will be a very interesting addition to Pakistan industry, especially for radiography. And as Ralph already mentioned, that the system has, you can ship it with ease and everything, and with all the safety feature. It is one of the best system.
Thank you very much. Those are very nice comments. We look forward to having one of the first systems there in your country, in Pakistan, and we look forward to seeing lots of photos of it doing the work. I think last comment, maybe just because of the times that we live in with traveling and restrictions and COVID, you guys can see that we set up full training online. We can also send someone there to do training with your technicians to ensure that they, are fully capable of achieving a LARA. But yeah, we are set up for online training once the system reaches the end customer. Gentlemen, with that, I want to say thank you very, very much. Firstly, to all of you who attended today. It was wonderful hosting you and showing you the new developments with our GamCPR system. Secondly, for our host, EDDIES Engineering, and letting all the customers there know that this opportunity exists and to come and see new technology. We appreciate it. And then with that, we will say goodbye and have a wonderful afternoon. Thank you very much for joining us.
Thank you. Thank you.
Thank you
Bye-bye.
so much.